Okay, this video is for Justin, dealing with phase shift and writing a trig function based on a given graph or picture. Here I've graphed the sine of x on a coordinate system in radian measure, and we're going to kind of work backwards to the answer that we knew we had. Here's a picture from his review packet. We know D was the correct answer, but the question was, how do we look at this graph and figure out that this is the right answer? And I'm going to give him some hints by looking at this graph. And the first thing I want to make note of is that some textbooks introduce the line y, in this case, equals 0 as the midline of the graph. It's actually the horizontal line that's halfway between the maximum value for the sine function and the minimum value. It's called the midline. The distance from here up to here is 1, and from here the midline down to the lowest value is also 1. So that's the amplitude. But the idea is, if you look at a graph and you can find its midline, that'll help you determine the altitude and whether there was an up or a down shift to the graph. Let me phase shift this guy with a plus pi over 4. And that would be the red graph. And notice what happened to this point on the midline. That's what you want to focus on. It shifted over here to negative pi over 4. So that's kind of what gives you the idea that there was a phase shift to the left by visualizing the origin on its midline. Where did it appear on this graph? If I put that plus 2 in here at the beginning, you see how this whole thing got shifted up, and now the midline is the line y equals 2 instead of the line y equals 0. So this point at 0, 0 had its midline shifted up 2, but now there's the phase shift. And then the only other thing that happened was we put a 4 in front of this, and that's what shot it up to 4 units above the midline and 4 units below the midline. Now, how do you know whether that should be a negative 4 or a positive 4 to get that amplitude to go up like that? Well, the key is that the original sine function starts at its starting point on the midline and goes up. And so here's our starting point on the midline, which has been shifted pi over 4 to the left, and it goes up. Watch what happens if I change this to a minus 4. Starting point in the midline, but it goes down. So that's how you know it's got to be a positive 4. So the idea is, again, find the midline. In our case, it's halfway between 6 and negative 2. We just average the 6 and the negative 2, the high y value and the low y value. 6 and negative 2, they add to 4. Half of 4 is 2. There's our midline. Kind of cuts the graph in half. The amplitude will take us the same distance above the midline and the same distance below the midline. And then just focus on, if it's cosine, of course the cosine function starts up here, 1 unit above the midline. So if we had looked at this point on the cosine function and tried to find out where it ended up, that would give us an idea of the phase shift. So I'll summarize one more time. If you have to write the equation of a trigonometric graph based on the graph, find the midline by getting the average of the maximum y value and the minimum y value. Draw or sketch in the midline. Then for the basic sine function, think about what happened to this point 0, 0. Where does the new graph hit the midline? Because that corresponds to the midline of the general sine function. So it hits it here. So there must have been a phase shift to the left of pi over 4. In your picture, you can kind of see that that's pi over 4 right there, halfway between 0 and negative pi over 2. Now that'll give you the phase shift. The plus 2 tells you what happened to get to the new midline. That is the midline. And then the amplitude of 4 just tells you, well, if you started up, you know it's a positive. If you started down, it must have been a negative. And there it is. So we can talk about this more on Sunday if you need to, but I hope that gives you an idea of what's going on.